In the previous video, we showed that the drawing order can change the appearance of our visual stimuli. We did that using a white circle and a black circle. And we found that things that are drawn later to the window object will essentially replace or overwrite the pixel values of things drawn previously. And we showed that the white or the black circle would appear on top of the other one. We're going to return to that concept a little bit later in this video, but what I want to do first is I want to show you the ability to draw multiple grating stimuli to a window. And we use these quite a lot in psychophysics experiments particularly. So what are we doing? It's the same setup as before in the previous video. We've got a 400 by 400 window presented to the screen. It's going to appear grey in colour. We're not going to use the circle stimuli in this example video, but rather we're going to use a grating. So grating stim. So if you're not familiar with how to create grating stimuli, I've got a video in this playlist previous, which goes through the parameters and how we set all those. So we've got the first grating. It's going to be set to win 0, which is the object up here. Now it's going to, I've set it to degrees now, so it's going to be 10 degrees. And it's going to be circle masked, and it's going to have a spatial frequency of 4.4 cycles per degree. So we down here, we are going to just have a little for loop, so it's going to present it 500 times, and we're going to draw the grating to the screen. So let's see whether or not that works. So it should be a sine wave grating, orientation 90 degrees. So I'm just reading that from up here because that's what we've set it to. And there we see here, and we can see down in the command prompt, we're updating the current frame. Okay, great. The simple grating stimuli is working. Let's add a second grating stimuli to the first. All right, so how do we do that? Well, it's let's make it half the size. So we've got 5, so this is grating number 2. Same window. It's going to be 5 sinusoid. It's going to have the same orientation, degrees, same spatial frequency. So how do we do that? Well, let's draw that grating 2.draw to the window. And let's see what happens. So we should see, in this case, a second grating half the size, essentially. What do we see? Huh? What's going on? We're not seeing the second grating. Why not? Because all we've done is we've just set the same stimulus to half the size. So when Psychopy overwrites those pixel values for the second grating, it's going to be exactly the same as the first grating that we've drawn. So of course we're not going to see anything. What can we do to check that? Well, let's set the second grating to be orthogonal to the first. So I did that on purpose because if you start writing these sorts of experiments or these sorts of visual stimuli and it's not working, just double check that you haven't done something wrong here. So here we go. We can now see the second grating in the middle of the, located in the center of the first, okay? How do we do that? I set the orientation to be orthogonal to the first. I could have done something like change the spatial frequency to something like 0.3. And so now that should have become apparent because the inner grating has a different spatial frequency to the outer grating, and so therefore there will be a change in the value. So as you can see, it's immediately apparent now that we've got the same orientation, but now the spatial frequency has been reduced. So we'll set the spatial frequency to the same again, and I like it to be orthogonal. Now, we've got 2 stimuli now. We've got grating 1 and grating 2. In the previous videos, or with Psychopy, we can set the parameters of grating 1 independently of grating 2. So let's see whether or not that works. So let's make grating 1, let's turn it into a drifting grating. How do we do that? Remember, we just increment the phase. That's why we've got it in the for loop, because every time we call the for loop, it's going to increment the phase by a small amount. So here we should see, what should we expect to see? We should see an outer grating that's drifting and an inner grating, okay, remember that's going to overwrite the outer grating. So grating number 2, that's static, so that should be fixed. So we should see basically a ring of drifting grating, if we've said it correctly. Yep, there we go. So the outer ring is actually drifting, the inner ring, it's static. So let's change the orientation now back. So you can see we're starting to do some quite complicated things with our visual stimuli by just creating or just adding 2 very simple stimuli back to back. So now we can see the orientation is changing. The orientation is fixed, but the outer is drifting. Now, we can make it even more complicated. Let's make grating 2. Underscore 2 dot set phase. Let's make the second grating go the opposite way to the first grating. I'm just trying to show you that each of these individual components to our stimuli are independent of each other. So you can see the inner bit is moving up, the outer bit is drifting down. Okay, and we can change the orientations, we can change the spatial frequencies of each of these independently. Now, we're going to return now to the drawing order. What if you don't want a drifting grating or a grating in the middle of your grating, like what we've just done there? Let's say you want to create a ring, a grating that is an annulus. How do we do that? Well, let's get rid of this second grating and let's think about it. Well, what do we want? We want a grating that's only a ring. So we want the central part of our stimulus should appear like the background, shouldn't it? So how do we do that? Well, let's make a circle. We'll call it circle 3. And let's set that to the same window. Now let's make it, say 3. We'll make the units degrees as well. Because we want a circle in the middle of our grating stimulus, don't we? What color do we want the circle? So line color will equal, well, we want it to appear like the background. So what background color did we use? Well, we used 0, 0, 0. So let's do the same thing. Line color is going to be 0, 0, 0. Let's make this nice and neat. And we want the fill color to also be 0. So now that's going to look like the back. Now what do we want? The circle is an n-sided polygon, so we want edges to be 128. Now, the position of the circle will default to the center of the window, so we don't need to change that at all. So we want to draw that, so we'll do circ 3.draw, grating, set phase, and then draw. And then this should hopefully work. So let's just clear the screen here. And we should now hopefully see an annulus, a drifting annulus. We see a drifting grating. What's going on? What do you reckon we've done wrong? Yeah, exactly. The drawing order, guys. Remember, we need the drawing order to be correct. We want to draw the grating, and then we want to essentially overwrite the center part of that drifting grating. So now, hopefully, if we've done it correct, and I really hope we do, we have, we've got an annulus. So there we go. This is the drifting annulus stimulus. This is why drawing order is also critically important for more complicated stimuli. We use drifting annuli quite a lot in higher order visual function experiments. Perceived motion and things like that, I think, can use drifting gratings, which are annulus or annular. I don't know what the plural is. It's not the point. Drawing order, guys. Make sure you understand that things that are drawn later will overwrite previously drawn things to the window. We'll leave this video here. Yeah, we'll leave it there.